Because we don't always have time in lab to cover TinkerCAD, this video will explain how to create the digital logic circuit simulations at the end of Lab 1. It is expected that you complete these circuits before leaving your lab session, so make sure you don't just rush out the door when you've finished circuits 1 through 3. The purpose of these simulations is to help you feel familiar with building a digital logic circuit on a breadboard on the computer before you build them using real equipment in the lab. If you build them correctly in TinkerCAD, you can use that TinkerCAD file as a blueprint to build the circuits in real life for Lab 2. In fact, some students find this to be so helpful that they wind up using TinkerCAD to build other lab circuits to help them bridge the gap between a circuit diagram and a circuit built on a breadboard with digital logic chips. First, go to your TinkerCAD account. This should be the account you have associated with our Digital Systems classroom. On this screen, I've navigated to my TinkerCAD account and I've created a new circuit. The first thing I'd like you to do is rename the file. If you look in the upper left-hand corner, there's some nonsense words that have been included as the file name. If you click that, you can write Lab 1, AND gate, NOT gate, OR gate, just some descriptive title that enables me to figure out what I'm looking at when I go and I look at your work. The next part is going to be putting all of the components inside the simulation. To get components, look over at the right-hand side. By default, only the basic components are selected. I like to make sure that I've selected all components, but in particular, I like to use the search bar to find the specific things that I need. First, we're going to need a breadboard. You can use just the regular one, a small one, but probably not the mini one, which will likely be too small to carry out what we're doing today. Next, you're going to need a power supply. I recommend that you use the thing labeled power supply and not a battery. In order to create input signals, you're going to need a dip switch. You can use the dip switch that has 4 inputs or the dip switch that has 6 inputs, but 1 input will not be sufficient. Depending on the circuit that you build, you will either need 1 or 2 input signals. For each input signal, you require 1 pull-down resistor. In this case, I will use 2 pull-down resistors for a 2 input signal circuit. Next, I'm going to need the actual digital logic chip. If you're doing the NOT gate circuit, that's the 7404. The AND gate circuit is the 7408. The OR gate circuit is the 7432. I will use the 7408. To display an output, we need an LED. And in order not to burn out an LED, we will need a single current limiting resistor. Now that I have all of the pieces in my workspace, I can start to connect them together. One thing you may want to do is rotate all of the components 90 degrees so that rather than looking horizontal, they look vertical. This can be particularly useful because the orientation of the breadboards that we use in lab is that vertical configuration. To rotate a component, you can simply use the rotate button or press R. Now that I have all of my components rotated, I need to place them on the breadboard. Remember that the purpose of dip architecture is that we have 2 unique sets of pins on both sides of the chip. In order to utilize them without shorting them out, they need to straddle the trench. So I'm going to place both the dip switch and the digital logic chip so that they straddle that trench. The resistors that we use in lab are 220 ohms. You'll notice by default, the resistance value in TinkerCAD is 1 kilo ohm. To change the resistance value, simply go to the pull-down menu, select ohms, and type in the resistance value that you're interested in. Now that I have all of the pieces correctly oriented on the breadboard in my simulation workspace, what I need to do now is connect all of the wires. For starters, make sure that you connect your positive terminal of your power supply to the positive rail on your breadboard. When we use positive connections to power, we need to make sure that our wire color is red. So select the appropriate wire color. Every wire that connects directly to power on the power supply through the terminal strips have to be red. Next, we can connect our ground connection. All of our ground connections should be black. Make sure that every connection that you have directly to ground uses a black wire. All of the intermediate signals, for example, the outputs of the dip switch or the output from the digital logic chip, can be whatever color you choose, so long as they are not red or black. In order to appropriately use the digital logic chip, you need to know what each of the pins on the logic chip does. This is known as a pinout diagram. You can find the pinout diagram for each digital logic chip in the appendix of the lab manual, on my website on the inventory of parts by looking at the datasheet, and in TinkerCAD, you can also figure out what each pin does by hovering over the pin and reading the tooltip. For example, this is an input pin, and an output pin of that same logic gate. I've completed building the circuit. I'm going to hide what I did because, well, that's going to be up to you to figure out. But I will show you how to test that your circuit works in order to determine whether or not you've done this correctly. What we need to do is check that the truth table of this circuit matches the expected truth table for each digital logic chip. In this case, I expect the truth table to be that of an AND gate. Click on Start Simulation. You'll notice that the power supply starts up and shows an output of 5 volts. When both of the inputs are at 0, the output is off. When A is 0 and B is 1, the output is off. When A is 1 and B is 0, the output is off. And when both A and B are 1, the output is on. If at any time you need to make changes to your simulation, you'll note that circuit components cannot be moved or added when you're in simulation mode. In that case, hit Stop Simulation, and then you can make changes to your circuit as needed. As long as you've created the simulation using the TinkerCAD Classroom account, I'll be able to see it.